All right, in this portion of 9.5, we're going to be multiplying and simplifying. So let's go ahead and get started on that. We're going to use the distributive property here. So we're going to take 7 times square root of 6. Now, I cannot multiply the 7 and the 6 because the 7 is on the outside of the radical and the 6 is under the radical. So I cannot multiply them. So we get 7 root 6 plus, and now 7 times 2 is 14. That's actually all we can do on this one because we can't break 6 down at all. They're not like terms. You'll see what I mean here in 187 when I talk about breaking it down. So we start with negative 6 square root of 32 minus 6 square root of 2. Now you could have plus a negative 6. That would be fine as well. What you have to realize in this one, though, is that 32 can be broken down. And so I'm going to make 32 16 and 2. And again, you could do your trees. Square root of 16 is 4. That 4 needs to get multiplied by this 6. So now that becomes negative 24. Square root of 2 minus 6 square root of 2. Let me rewrite that. Now we have negative 30 square root of 2. All right. So we multiplied using the distributive property. Then we broke down the one we could. You could actually break them down first. That would be just fine. Like I could break 24 and 54 down first. In fact, let me just show you that method for fun. I'm going to break 24 down into 4 and 6. It's 4 times 6, and the square root of 4 is 2. So that becomes 2 root 6. 54 is going to be 9 and 6. 9 is 3, so that becomes 3 root 6. So now what we're looking at is the square root of 5. Let me rewrite that. I don't like the way that looked. Times 2 square root of 6 minus 3 square root of 6. Now, by breaking them down first, right, like when I came back here, let's go just review here. I multiplied, then I broke them down, and I was able to combine them. Well, here, I'm going to go ahead and combine them right now. And so now I have the square root of 5 times a negative square root of 6, negative 1 square root of 6. And now I'm actually going to multiply these two together, and that becomes a negative square root of 30. So I think this one was much easier by breaking it down first. If I hadn't broke it down first, I would be taking 5 times 24 and then 5 times 54 and then trying to simplify those. So when the numbers are a little bit bigger, it might be easier to simplify first. And we could have absolutely simplified 32 right away. We would have ended up with the same result. Okay. So I'm going to use that same concept, and I'm going to go ahead and make that a 9. So I'm going to make this a square root of p times the square root of p minus 9 square root of u, right? Square root of 81 is 9. Now I'm going to multiply. Square root of p times square root of p. Now, technically, we're saying, well, that's the square root of p squared. And I'm going to talk about that here more in a second. Now, I'm going to go over here, minus 9 square root of pu. Oh, my. So when we multiply this out, we can only multiply those things under the radical together. So, like, the p does get multiplied by the u, but the 9 is actually being multiplied by, like, this 1 that's out here, right, that we don't write. All right, now p squared, square root of p squared is just p minus 9 square root of pu. When you multiply the square root of p times the square root of p, it really is the square root of p squared, but you don't actually have to write that. You could just go right to p, because we've talked about that in the previous section. We talked about that concept of when you multiply a radical times itself, it just removes the radical sign. Okay. All right, I'm going to go ahead and break these down if I can. So I can work with 27. That's 9 and 3, which is then 3 square root of 3, keep the b there. Okay, so I'm going to rewrite this. It's going to be the square root of ab times the square root of 5a plus 3 square root of 3b. Distributing, I'm going to get the square root of 5. When I multiply the a's together, right, when I multiply these a's together, that just brings an a to the outside because it's an a squared, which then brings an a to the outside, and still have a b here. plus, I'm going to use that same idea here. There's a 3 on the outside. When I multiply the b's together, right, now I'm talking about, let me grab a different color here, this b and this b, that's going to bring a b to the outside as well, square root of 3a. Lots going on here. And I actually not add these two together at this point. They're not like terms, so that's actually our answer. This answer is an expression, and so it has multiple parts to it. So they are going to get a little bit messy at times. I think the questions kind of increase in difficulty. So like when you're looking at number 94, expect that one to be a little bit more difficult. And it's actually fifth root. So remember, you have to have 5 of them to bring anything to the outside. Okay. Let's look at 195. You could use FOIL on this one, right? First, outside, inside, last. I'm just going to use the distributive property twice. So when I take square root of 2 times square root of 2, that's just 2, right? It's actually the square root of 4, which then becomes 2. But I'm just going to write it that way. Square root of 2 times a negative 3 is a negative 3 root 2 plus 8 root 2 minus 24. Now I'm going to combine my like terms. 2 minus 24 is one set of like terms, and negative 3 and positive 8. You could put these in either order. I'm going to put the radicals first for no real good reason. So 5 square root of 2 minus 22, if I'm not mistaken. Okay. Here we go. 5 times square root of 7 is just 5 root 7. 5 times the square root of 2 is 5 square root of 2. I cannot put those together because one's 5 is on the outside, 2 is underneath, so they don't get multiplied together. All right, so now we've got plus 2 square root of 21. The 2 is, again, being multiplied by a 1 on the outside, and 3 and 7 get multiplied together. Finally, plus 2 root 6. That's it. I cannot combine any of these. I can't break 7 down, I can't break 2 down, I can't break 21 down, and I can't break 6 down. You might be thinking to yourself, 21 is 7 times 3. Neither of those are perfect squares, and those are both primes, so you're done. You can't, there's nothing to bring to the outside. So this is actually finished at this stage. Bit of a weird problem there. All right. We're going to do 4 more. Okay, let's do 199 here. Woo! All right. Get a new color here, and let's use this Kool-Aid color. All right. So when I multiply these together, 8's the only thing on the outside, and then I get the square root of 6pq's. Okay. And now we have 5 on the outside. And now when I multiply 6p times 6p, I just get 6p. So I'm not writing it under a radical, because when you multiply a radical times itself, it just removes the radical sign. Okay, get rid of all this, because now we're here. Negative 2 times a is negative 16, and when I multiply square root of q times square root of q, I just bring a q to the outside. Now that's negative 10, because 2 times 5. And square root of 6pq. Okay, so first thing I'm noticing is that I've got like terms here. So I'm going to put those together, and that's going to be a minus 2 square root of 6pq, and your order doesn't matter here. This becomes plus 30p minus 16q, and these two are not like terms, so we cannot combine them, so we are done. Notice our answers are starting to get a little bit messier. They're becoming more of expressions versus terms, right? So they have multiple terms. Okay, this is not just 11 minus 5. You can't just square the square root of 11 and square the 5. So really what we're doing is we're really thinking about it as being written twice. Right? Instead of a squared, it's being written twice. So let me grab a red here. So now when I multiply square root of 11 times square root of 11, it's 11. When I multiply square root of 11 times a negative 5, or negative root 5, that becomes negative square root of 55. Similarly, down to negative square root of 5 times the square root of 11 is another negative square root of 55. And then negative square root of 5 times negative square root of 5 is a positive 5. Combining those, I have 16 minus, now combining these, 2 square roots of 55. Because both of those are a negative 1 square root of 55. Okay, same thing here with 203. Yeah, all right, we'll go ahead and do this one. Why not? So I'm just going to add another square root of x minus square root of y and multiply them out. Square root of x times square root of x is just x. Square root of x times a negative is a negative square root of xy. Another negative square root of xy. And then plus just y. So now I have x minus 2 square roots of xy plus y. And again, order does not matter. Okay. These ones are interesting because you have the exact same parentheses, only one's plus and one's minus. So something pretty interesting happens here. And if you see the trick, it makes it much quicker. So 4 square root of 3 times 4 square root of 3. That's actually 16 times 3. And again, the 4 times 4 gives me 16. Square root of 3 times square root of 3 gives me 3. Now I have minus 4 square root of 6 plus 4 square root of 6 minus 2. These two cancel out. So when you have the exact same parentheses, one's plus, one's minus, you actually lose your middle term, and it becomes the first term squared minus the second term squared. So that's 48 minus 2, or just 46. All right, last one. We're going to see that same thing happen. So you really could use this shortcut by squaring this minus this squared. So I have a feeling we're going to get C minus D when all is said and done here. Okay, square root of C times square root of C is C, minus the square root of CD, plus the square root of CD, minus D. These two cancel out, and as predicted, C minus D. Okay, so again, left you about half of these to do to work your way through. Again, reach out to your teacher if you are struggling with these, and good luck.